Hello everyone, I'm Xiaogang. Okay, in this lesson we're mainly going to do a supplementary recording. As we mentioned before, we wanted to test the audio of this microphone. We temporarily wrote a method to test it because I thought the engine layer should have relevant APIs to get the current audio or Windows. We'll get the current Windows microphone volume from Windows, but I looked for it and couldn't find it. So we'll just write a temporary one to test it first. So what is this API called? It's called getting our volume level. Let's look at the name here. Let's change it. Okay, and here we'll change its type to. It's a pure, and this part is for getting our volume level. So how do we get it? Of course, we haven't written it yet. We've only set up the blueprint interface here. This part is the same. We definitely need to go. Return 1, get an AudioCaptureSubsystem. If it is not obtained, we consider that it is basically not supposed to happen. It should be obtainable, so we just let it crash. Okay, here we get our AudioCaptureSubsystem. It should have a method called getValues. In this subsystem, we need to include the header file. So at the very top above, obviously this header file. Okay. So after this header file is included, we don't have this method yet. So we go to this AudioCaptureSubsystem. We might generally need to give it a friend because we don't want users to directly access it this way. Okay, let's add a friend here. Okay, we need to give it a volume size. Such a method. As for this method, it's actually just a method like this. Let's put it here. Okay, so this method gets the volume size. Then surely we need a method to set the volume size. Then we create it here. Then we definitely need a variable. Let's call this variable volute size. For this set variable, we set its volute size equal to the incoming volute size. Okay, this variable hasn't been declared yet, so we can just declare it here. As for this variable, it doesn't really need to be static. We'll just move it to the bottom. So how do we modify this value size? The modification here will involve some calculation because we are in our. Let me check. It should be in our edugeler, this place of edge alert. Let's take a look here. Here we will get such a segment of sample point data evaluation. We keep 1. How to calculate the audio size. So how do we definitely need to calculate it through some mathematical methods. So first we prepare a float value. Then we take its sample point. We just do this. We square it. Square each number and add the squares. Just to square it, square this sample. Then we accumulate it. After adding it up, we then take a square root, process its number of sample points, then take another square root. This is a mathematical formula. It's square, right? After taking the square root, since we are now in the audio thread, we will dispatch an asynchronous task. We let it go to the main thread to modify it. Then we need to provide this. Okay, we have this pointer. We can just modify this thing through this pointer. If this object still exists, we will modify this value. Then, when we modify it, you must have a place to reset it to 0. That is, you need to set the volume size to a simple 0 reset. Then we take this piece of code and copy it inside this clear. When we clear the data in this clear, we also clear the accumulated audio size. Okay. Then we clear it here. Good. Then we pass a 0 here. Just attach it as well. Okay, then let's compile it. It should be fine. Okay, now let's launch it. Then let's test what the effect looks like. Actually, we are doing a mathematical calculation here. Just some simple mathematical formulas. Okay, Then let's go to our level blueprint. It may not be accurate here, not necessarily accurate, but we can use it for now in the tick event. Then we print it, stream. This should be XJ sample. Then it should be this. Then to our volume size, let it print every frame. Then for printing in this level, we better give it a key. We give it a volume key. Okay, let's print it. Let's see the effect. As for the time, we set it to 0. Okay, now let's start it. It should still be 0 by now, right? But now we enable audio capture. You'll notice that as soon as we speak, its audio count starts to increase. If we don't speak, it becomes very small. Actually, this way we can roughly observe it. That is to say, it is indeed capable of symbolizing to some extent whether you are speaking or not. But perhaps at this level of precision, some coefficient adjustments may be needed. Okay, this is a temporary one. Okay, we have finished processing. Let's pause. This is just a temporary processing method. You can see that whenever we are speaking, its amplitude should be in the double digits when we stop speaking. It will gradually drop. It has dropped below 3 digits. You can see. You see? Right here, when we first started it up, there was actually no sound. Right? You see, this situation is when we are speaking. We can start it up again to show everyone. You can see it still goes up like this here. You can see that if we don't speak, it's roughly in the 3-digit range. When we speak, it's in the 1-digit or 2-digit range. There is such a value in both cases. Okay, this is a relatively simple method, so that everyone can. That is, you can observe, that is to confirm whether someone is speaking. It's temporary. It should be. Actually, there should still be a quite suitable AP. In this case, we'll handle it temporarily, just like this. You can temporarily observe and handle it. Okay, this lesson, we will stop here. Thank you, everyone. Of course, writing it this way is a bit wasteful. Actually, you can add a boolean or something to get it. The way he wrote it is somewhat good, but it should be fine. It doesn't have much of an impact, because it's just a simple task done within a tick.